Hello everyone, Tim here. Just as Richard and I stated in our previous video, he and I like doing algorithms and we like helping people with algorithms. So we're planning on making some videos for those who may be starting to study for virtual whiteboarding, or for those individuals who have a little bit of issues with whiteboarding and the logic, maybe questions that you should ask throughout it, or even how to conduct that virtual whiteboarding if you just need a little bit more practice with it. So in this, I'm going to go ahead and run through a sample whiteboarding question, and then also walk you through what you should be doing throughout it, and also the logic of this problem. So in this case, we're going to go with an interviewer who is telling you that you are going to need to write an algorithm that is past an integer array, and you want to find the minimum and maximum values within that array. So one of the first things that you want to do right off the bat is you want to take notes of what is actually being asked of you. So you're going to do an algo that takes an integer array and returns the max and the min. All right. So right here, they told you that you're going to need to pass out two different values. So this is where you should be asking clarifying questions and possibly propose your own output. So in this case, we could use a tuple, we can use a list, we can use an array, we can use multiple things to pass out to return these values, but we're going to go with an integer array. So you would want to ask them, are you okay with me using an integer array where the first element is the max and the second element is the min? And if they say yes, then you'll go ahead and put that down as a note also. And then we'll go ahead and say that we're going to make it the max and the min. All right. And then you would want to ask different clarifying questions that may pop into mind. So is this ever going to be an empty integer array? And in this case, we're going to go with no, it's always going to have at least two values. So there will always be two numbers in the array. And you can go ahead and think about any other clarifying questions. Is it going to have negatives? But in this case, when we're finding the minimum max, that really isn't going to affect you. These are things that you should be thinking of, but aren't necessarily required to ask unless it will be an issue. So in this case, if it is a negative or it is a positive, it's kind of irrelevant because it should work for a wide variety of numbers when you're building this algorithm. So the next thing we're going to want to do is do this based off of a test when you build your algorithm. So we're going to go ahead and establish that right now. So we're going to say, okay, for an example input is 1, 8, 19, 0, 9, 45, and then let's say negative 5 for our example input. And you're going to ask the individual if for this given input number of values, would the correct answer be 45 and negative 5? Since the greatest value throughout this integer array that would be passed is 45, and then the least value is negative 5. And they're going to say yes or no. And in this case, let's go with they're going to tell you yes, because that is proper. 45 is a maximum number, negative 5 is a least number. So now is where you can go into pseudocoding. So pseudocoding is essentially your coding process, but without actual syntax. So it's really just you thinking about it, jotting it down so you can get your head wrapped around what you're going to do. So I like to start off with the signature itself, make sure that I have everything in there. So we're going to do a signature. Oh, do that typo. So signature, and we're going to have the output be an integer array since we already established that. So output is going to equal an int array. And then we were already told that our input is going to be an integer array also. Now we're going to have to think through this. Since an array does have a defined length, we're going to need to create a new array to pass out of this method to ensure that it works properly. So we're going to go ahead and create a new array. One of the first things we're going to be doing in our algorithm. And then next, we need to think about those elements of the array. If we set them both to 0, say that we have all negative numbers, that could cause an issue because there will be multiple numbers that are less than 0, of course, if they're all negative, but there won't be any number that is larger than 0, but 0 won't actually be within our array. So we do not want to do it like that, so we need to think about it. So we're going to set the values of the new array to elements of the input array. Now we need to think about the actual comparison of these elements. And for this case, I'm just going to go ahead and use a for loop, so we can write down that for loop for comparison. And then lastly, we're going to need to return the result. So now at this stage in any whiteboarding session, you have your clarifying questions. If any more questions do pop up as you're coding, absolutely feel free to bring those up to your interviewer. And we also have our example input and output that we've established and had approved by our interviewer. And then we also have our pseudocode that gives us a baseline, a little bit of time to think about how we're going to work through this problem. So now we're actually going to go ahead and start constructing this algorithm. And throughout it, I'll walk you through a little bit of why I'm doing the things that I'm doing so that hopefully it can help you with actually creating an algorithm yourself. So we're going to go and we're going to call it public static. So why I'm doing public static is public is going to make it to where anything throughout your program can see it and access it. And then static is making it so that if it is in a class, you don't have to instantiate that class itself. And you can also call it from another static method. So in this case, your main method is a static void method. So we're going to do public static. And then we already established that we're going to be outputting an integer array. And then we need to give it a name that actually means something. So you don't just want to call it problem1. You want to call it something that actually has meaning. So we're going to call it get max and min. Now the reason why I capitalized the G, this is Pascal case instead of camel case, is because it is public. So you always want to make the first letter capitalized, which is Pascal case. If it is public, if it is not public, so say that I left public off and it's automatically private, then you would do a camel case, so the G would be lowercase and the rest would be the same. Now we need to define our parameters here. So a parameter is really just what's being passed into this algorithm. So we're going to be passed an integer array, and we'll just go ahead and call that input. And now we have our signature and then our method body right here. I always like to do the curly braces right off the bat in case I am going through it and I may forget them later and don't catch it, so I like to do them right away. So as we stated before, for our output, we're going to need to create a new array. So we're just going to go ahead and do that. So we're going to do an integer array, and we're going to go ahead and call it result, and we're going to make it a new array. So you do that with the new keyword, and then integer array, and we need to define the length of this array. So we're going to make it 2 elements long, since all we need is the minimum and maximum values. And then as we also stated, we're going to need to set those to elements of our input array. So we're going to have the result 0 index, which is our first element of the array, since arrays do start off at index 0. So if you have an array of 10 different numbers, the last element of that array is actually going to be index 9 instead of 10, since we do start off at 0 with the indexes. So the first index of our result array, we're just going to go ahead and equal that to the first index of our input array. And we're going to do the same exact thing with our second element so that we can get a proper comparison here. All right, so now we've already went and we've created our new array and we've set the values in that new array to be ones from our input array. So now we're going to need to actually do the comparison. And before I said that, I'm going to use a for loop. I personally like for loops I like to use them often because I have a lot of control over what actually happens with each iteration through the loop. So we're going to make a construction for it, and we're going to go ahead and do our initializer right here. And I'll explain why I'm putting these in. And we're going to do while I is less than input dot length. And then each time I plus plus. Now why I'm doing this. So this is our initializer right here. So this is creating a local variable that is accessible only for this loop. And we're starting off at 0 since, as we previously said, the first index of any array is index 0. And this is our condition. So this loop is going to run until this condition is no longer true. So we want it to run to the very end of this array. So the length, and then we're doing less than, because as previously stated, if we have an array of 10 different elements, the last element is actually index number 9. So that's why we did less than. So once this hits 9, it's actually at the end of the array. And then if it goes to 10, we're going to get an index out of bounds error. So that's why we stop it once it's not less than the length. And then each time that the loop goes through, we're going to be adding 1 to I right here. So first time it's going to be 0, then 1, then 2, then 3, then 4, then 5, then 6, and so on and so forth, until this condition is no longer met, and it's going to break out of the loop and do the rest of the code down below. So for our comparison here, we're just going to go ahead and use some if statements. Easiest thing for condition. So we're going to do if input I is greater than result 0. Then we are going to set result 0 equal to input I. And then we're going to use an else if statement here. Go ahead and explain that also in a second while we're doing that. And we're going to do the opposite for the minimum value. So if input I is less than result 1, then we are going to set the second element right there. So result 1 is equal to input I. And then lastly, we are going to need to return that array, which we named result. So now going into why I chose these specific things right here. So within an if statement, these things right here are simply a condition. So if this is met, then this will be executed. You can put it in line if you're only going to be doing one action. If you're going to be doing multiple, so say that I was setting the first element to the input element, and then I also wanted to console write line. Then I would need curly braces, and I would need to put all those things within the curly braces. If not, we can put it in line. It makes it look a little bit cleaner when you actually run through it. So this if statement, so we're saying if the index, so I, of the input array is greater than the first element, which we said was going to be our max of our result array, then we're going to go ahead and set the max to that number. And then we're also going to go and look at the minimum value. So we're going to say if this element within the input array is less than the minimum value, which we designate as the second element, so index 1 of our result array, then we're going to set the new minimum. So now why I used a else if statement here instead of just another if statement is because this doesn't necessarily need to be evaluated if the top is true. So if this is already met, so our number is greater than our maximum, then it's not going to be less than our minimum. So there's no reason to even evaluate this and waste a little bit of processing power. It's not very much, but there's just no point to it, so we can just use an else if statement. So At this point in any whiteboarding session, this is where you have already explained your logic. So everything I'm doing so far, you're going to be doing the same exact thing. Talking to the interviewer, telling them why you're putting things in what place, asking any clarifying questions if they pop up. If you have to change your pseudocode, you can go ahead and change it while you're coding. So you may go and set this to 1 and then realize, actually, no, I want to do it to 0 instead. You can go ahead and do that. Feel free. You don't have to stick 100% to your pseudocode. And then you want to go through and look and see if you have any syntax errors. So did I capitalize things in places that they shouldn't be capitalized? So did I capitalize result down here, but I didn't do it up here when I actually declared it, or anywhere else? So we're going to go ahead and look through, just do a quick skim, make sure that all of our semicolons are there, all our curly braces are there, which they appear to be. So now you're going to go ahead and walk through this actual code. So for this, I'm going to go ahead and create a max and a min right here. And the only reason I'm doing that is so it's a little bit easier to walk through. So we're being passed in this array, and you are going to use your example one because you built it around that, and it's just easier to use that. And it shows that you started off with a goal and you met that goal. So our maximum, we set it to the first element of our input array, so 1, and we also set our minimum to that, 1. So we created the array, and now the minimum and maximum, so our first element and our second element, are both equal to 1. So now it's going to come down here into the loop. And it's going to be looking at the first index. And it's going to look and see if the first index, which is 1, so is 1 greater than 1? No, it's not, so this is not executed. And is 1 less than 1? No, it's not, so this isn't going to be executed. So now it's going to go into the next iteration of the loop. So now I is going to be 1. So it's going to be looking at the second element of the input array, which is 8. So it's going to come down in here, and it's going to say, if 8 is greater than 1, then the now maximum is equal to 8, which 8 is greater than 1, so our max is now 8. And as we previously stated, if this condition is met, this will not even be evaluated. So it's going to go through the next iteration of the loop, and now I is equal to 2. So it's going to be looking at the third element, which is 19. So it's going to say if 19, the third element, is greater than result 0, so our max, then the result is set to 19. So since 19 is greater than 8, the first element, which is our maximum, is now 19. So now I is once again increased, so now we're going to be looking at 0. So it's going to go and say if 0 is greater than 19, that's not the case, so this is not going to be executed. And then it's going to go down to our else if, since this was not executed, is 0 less than 1? It is, so now our minimum is now 0. Now it's going to go and the next iteration of the loop and increase I once again. So now it's looking at 9. It's going to say, is 9 greater than 19? No, it's not, so not met. And 9 is not less than 0, so not met. Now, I is once again increased since we went through another iteration of the loop. And now we're looking at 45. So it's going to go in and say, if 45 is greater than 19, then our new maximum is 45. So now our maximum is 45, and since this condition was met and executed, the else if will not be evaluated. So it's going to go through once again, and it's going to increase I, and now we're going to be looking at -5. So now it's going to go and look and say, is -5 greater than 45? It is not, so it's going to go into the else if, and it's going to say, is -5 less than 0? It is, so now the second element, which is our minimum, is now equal to -5. So by walking through that, we just demonstrated that with this specific method or algorithm, if you want to call it, we were passed an input and we output exactly what we said that we were going to, which is 45 for our maximum and -5 for our minimum. So this is a point where you would have already you would have asked your clarifying questions here. Then you gave an example input and output. And then you did your pseudocode that gave you a little bit of time to think and also laid the framework for how you're going to be actually doing your code. And then you would have gone and walked through the creation of your method, explaining why you put things in individual locations, and then you ran through it and demonstrated that this method can solve the problem that you were giving. So at this point, you have went through key things to really remember are you want to be talking, you want to be communicating with that interviewer, you want to be making sure that they understand your thought process, because you may be able to run through this super fast, explain absolutely nothing, but that doesn't show the interviewer your thought process. And that's really the main thing that they're looking for, is how you think about things, how you think about solving things. Of course, if you can solve it, but it's really your thought process that they're really looking for. So I hope that this video helped you out if you were just starting the whiteboarding process. If it didn't, we're going to be doing some more that are a little bit more complicated if this was very obvious to you. And if there's anything that you hope that we will focus on in the future, go ahead and let Richard and I know, and we will try to facilitate that to the best of our ability and help you out with that. Thanks for watching. Bye.